Hello friends, welcome back. Now we are going to start the last part of our chapter mensuration, that is problem set 6. Now in this problem sets there are all the types of problems from all the topics of this chapter. It's a combination chapter. Okay, so let us start or let us discuss with the first problem. Observe the nets of solids given below and identify the solid. We have already seen the solids like your cuboids, your pyramids and your prisms. So how will we identify the pyramid? The vertical edges or the slanted edges are always triangle. Okay, so the figure they are given is something like this. If you cut your paper in this shape and you fold this on these lines, all these triangles will meet at single point and you will get a pyramid. Okay, one more figure they are given. Now in this figure, mind well, I have not drawn the figure very good. When you fold on all this, what you will get? You will get a cube. Now third figure is they are given is something like this. You can easily see that these two are pentagons. Okay, this is the base and this is the top face, and whereas all the vertical faces are rectangles. That means this is a prism, and since there are pentagon as a base and top, this is a pentagonal prism. These are very easy to identify. I am again telling you, whenever the rectangular vertical faces are there, slanted faces are there, then that is a prism. When all the faces meet at single point and slanted faces are triangles, those are the pyramids. So very easy. Now let us see question number 2. The area of a circle is 314 centimeters square. Question number 2. Area of circle is 314 centimeters square, and the area of minor sector is 31.4 centimeters square. Area of minor sector is 31.4 centimeters square. What they asked? Find the area of major sector. Now this is very simple example. If they are given the area of circle and area of minor sector is given. Now in circle there are two sectors. One is the major sector and one is the minor sector. Suppose this is your circle and this is a sector, then this is a minor sector and this is a major sector. So when the area of circle is given, minor sector area is given, the major sector area just subtract. Very simple. Let us go ahead. Question number 3. Prove A is equal to half. Question number 3. A is equal to 1/2 CR. For a circle having radius, circumference and area R, C and A. So R is the radius, C is the circumference and A is the area of a circle. How we are going to solve this? You know the area, formula for the area, you know formula for the C. Let us equate it. So left hand side, the area is pi r square and right hand side is half, circumference is 2 pi r into r. So in this case these two will get cancelled, these two will get cancelled, and we get r square is equal to r square. So it is proved. Very simple, may hardly come for 1 mark. Okay, let us go ahead. Problem number 4. The radius of a circle is 3.5 centimeter and the area of the sector is 3.85 centimeters square. Find the length of corresponding arc and measure of arc. Very simple example. What they are given? They are given the radius. Example number 4. Radius is 3.5 centimeter and area of the sector is equal to 3.85 centimeter. 3.85 centimeters square. Okay, what they are asked? Find the length of corresponding arc and measure of arc. That means we have to find length and theta. We know that now there are only two formulas, okay? The area of sector is equal to r by 2 into L, that is the length of arc. So by substituting area given, radius given, L you can easily find out. Once you find the L, you can directly use the formula theta by 360 is equal to L upon 2 pi r. So now by using this formula, you know that L is known, R is known, you can easily find out the theta. There is another formula which is the direct formula. Now this formula is derived from the direct formula, okay? But there is a direct formula, area of sector is equal to theta by 360 into pi r square. Even by substituting in this formula directly, you can find out the theta. Now please pause your video here and quickly find out the answer for L and theta. Please do it now. The answer is, the length of arc is 2.2 centimeter and theta is 36 degrees. Please check your answer. Very simple example, just substitution of formula. Since these are the initial examples, I am solving it here, but later on we are just going to discuss. I'll show you how to solve and you are going to solve. Let us see fifth example. The length, breadth and height of a cuboid are in the ratio 5:4:2. The length, breadth and height are into ratio 5:4:2. If the total surface area, now length, breadth and height is equal to 5:4:2. The total surface area given is 1216 centimeter square. Find the dimensions of the cuboid. Now if the length, breadth and height are in this ratio, I can say that L is equal to 5x, B is equal to 4x and H is equal to 2x. Now we know what is the formula for the total surface area of the cuboid. Okay, so we'll substitute in the formula. Now what is the total surface area of the cuboid is? Total surface area is 2 into LB plus BH plus HL. Total surface area is given. By substituting this value, only x will be unknown here. Okay, you will get answer in something x square, you will get the answer, and from that you can easily find out the x. Once you get the x, you can find out L by 5x, B by 4x and H 2x. So please pause your video and quickly solve this. Very easy example, you don't have to do anything here. Okay, let me solve this. L into B, that is 20x square, plus B into H is 8x square, plus H into L is 10x square. So you have 38x square. 38 into 2, we have 12, 16 here, 2 into 38 into x square. Just solve this and you will get the value of x. Please pause your video and quickly find out the value of x. The value of x here is 4 centimeters. So we have L is equal to 20 centimeter, B is equal to 16 centimeter and H is equal to 8 centimeters. Please check your answer. Find the perimeter of each of the sectors. I'll just solve first and you have to solve the second, which is given in your book. The first is, one sector is given, angle given is 40 degrees and the radius given is 8 centimeters. This is the first figure they are given. Theta is given, R is given, Now you have to find out the perimeter of each of the sectors. Now how will you find out the perimeter? Very simple. First find out the length of arc and add the two radiuses there. So you will get the perimeter. Very simple. What is the L equal to? L is equal to theta by 360 into 2 pi r. And to this answer you should add, that is 40 upon 360 into 2 into 8. So you will get the length of arc, add 16 to it and you will get the perimeter of this sector. Please pause your video here and find out the answer. Now in this case, either you can take 22.7 here, or you can take 3.14, or you can simply keep it in the pi, in the form of pi. Okay, all are valid because they are not given any value for the pi. You can calculate, or you can just keep it simply as a in terms of pi. Okay, so this is very simple. I'm not going to even solve this. I'm showing you what is the second figure. In the second figure they are given the angle is 126 and radius is 10 centimeter. Substitute values in this equation and then add 2 radius and you will get an answer. Okay, please pause your video and quickly solve this. Very simple. I'm not going to solve this. Okay, let us go ahead. They are given two figures, similar figure to this. One is like this, second figure is slightly tilted. What they want to find out? The area of the total area they want to find out. Okay, shaded region. I have not shaded this figure because it will look very complicated here, but they want to find out the area of this complete shaded region. This angle they are given as 90 degrees. That means this area is 1/4 of the area of circle with radius r. So your area, total area is pi r square by 4 plus the area of this sector. What is the area of this sector? Theta by 360 into pi r square. Just substitute, this is r1 and this is r2. This is 4 centimeter, r2 is 3 centimeter and theta is 30. So just substitute the values and find out your answer. Please pause your video here and solve this example. The answer is 19 pi by 4. You can keep the values in terms of pi, doesn't matter. Okay, or you might have got 3 upon 4 pi plus 4 pi. By solving this I got 19 pi by 4. The second figure they are given two sectors. For the first, the radius is 9 and angle is 70 degrees. Radius is 9, angle is 70 degrees. And for the second sector, the radius is 8 and angle is 50 degrees. Now you have to find out the combined area. How will you do it? Very simple. There is only one formula, theta by 360 pi r square. So apply that formula for the first part, apply the same formula for the second part and just add them. Very easy. Just pause your video and solve this example. So the final answer is 63 pi by 4 plus 80 pi by 9 centimeter square. Very simple. You can keep in terms of pi. Mind well, whenever such kind of examples comes in final exam, generally the figures are such that either by taking the value of pi 22 by 7 or 3.14 you get the final answer very easily. That is, the figures are easily divisible by the things. Okay, so here they are asked the answer in terms of pi, so we are giving answer in terms of phi. If they are not given, just don't try to solve this and find out the final answer. Okay, so let us go ahead and solve the example number 8. They are given find the area of shaded region. Now this example was in the October 12 paper for 4 marks. Okay, and this is a direct substitution of formula. That means all these 4 marks are allotted for the calculation work, and it depends on whether you remember the formula or not. Let us see the figure. The angle given is 60 degree and radius 12 centimeter, and they have asked us to find out the area of shaded region. Now you know that this shaded region is nothing but a segment, and we have direct formula for the area of segment. So area of segment is equal to r square into pi theta by 360 minus sine theta upon 2. Mind well, you should know this formula. The formula is very important because just by substitution of formula, r is given, theta is given, and you have to find out the final value. So only for the mathematical calculation they are giving you 4 marks. So the first thing, you should remember the formula, and second thing, your arithmetics should be very, very perfect. Okay, so pause your video here and quickly solve this. So the answer is 13.08. Don't forget to write centimeter square. Unit is very important. Let us go ahead and example number 9. The figure is given something like this. A circle is there. Then angle of this sector is given as 30 degrees and radius of the circle is 12. Now in this case, they want to find out 3 things. First, area of sector. Second, area of triangle, this triangle OPQ, and third thing, area of this segment PRQ. Very simple example. First of all, you know radius, you know angle, so you can find out the area of sector, complete sector, very easy, theta by 360 pi r square. Okay. Second thing, you can find out the area of segment separately. You know the formula for area of segment. Formula for the area of segment is r square into bracket. Just now we have seen in the previous example, r square into bracket pi theta by 360 minus sine theta upon 2. So in this way you can find out the area of segment. Now subtract the area of segment from the area of sector and you will get the area of triangle OPQ. But suppose in this case, if this is not required, if area of segment is not required and you have to find out only sector area and triangle area, then there is one more thing, one more way you can find out the area of triangle. First of all, I am drawing the tangent on the line OQ through P. Okay. Now in this triangle, this is the angle 30. So what is the sine 30? Sine 30 is PM upon OP. So sine 30 is PM upon OP. So here in this case, that is PM upon 12, and sine 30 is nothing but 1 upon 2. So PM is 6 centimeter. Correct? Now if you have this 6 centimeter, what is the area of triangle? OQ is a radius. So area of triangle is equal to half base, that is OQ, is 12 into height is 6. You can even find out by this way. So it depends on you whether you want to find out the area of sector, area of segment, then subtract, or you want to find out the area of triangle separately. My choice is find out the area of sector and area of segment and just subtract the area of segment from area of sector and you will get the area of triangle. Very easy. The example is absolutely the direct substitution of formula, but I just shown you this example to show you this. So now pause your video and find out these three answers: area of sector, area of segment, and area of this triangle. Okay, please pause your video and solve this. The area of sector is 37.68 centimeters square, and area of this segment is 1.68 centimeters square. Or you can do like this: find out the area of sector, then find out the area of triangle by this method, by finding out the height, and when you subtract the area of triangle from the area of complete sector, you will get the area of segment. In either way you can solve this example. Okay, but as per my view, the first method is better because you know two direct formulas for segment and sector. Okay, let us go ahead. Let us see example number 10. A figure something like this is given. This is a circle. At Q there is a tangent QR. Okay, radius OQ is 10 and they are joined O and R. Okay, they are also given the length of OR is 20 centimeters and they are asked us to find out the area of shaded region. So first of all, what you will do, this is a right angle triangle, so by Pythagoras rule, that is 10 square plus this side square is equal to 20 square. You can easily find out the length of QR. Very simple, you can find out the length of QR. After that, okay, if you want to find out the shaded region, what you have to do, you have to find out the area of this triangle and subtract the area of this sector from it. Okay, now to find out the area of triangle, you need a base length, which you will find out by Pythagoras theorem. And to find out the area of this sector, what you need this angle. Angle O you should know, radius is known, so you can find out the area of sector. Now the question is, how will you find this angle? Very simple. Can you see this sine? If I consider this angle, you can take directly this angle also, because for calculation it is oral. I am taking this because I can easily see this is a 30 degree. Why? Because the sine of this angle R, sine R is 10 by 20, that is opposite side of upon hypotenuse, that is 1 upon 2. But when sine R is equal to 1 upon 2, then R must be 30 degrees. So R is equal to 30 degrees. If R is 30 degree, Q is right angle, this must be 60 degrees. Generally, you will, in your book or digest or in your classrooms, what they will suggest, they will say that sine of this angle is equal to this side upon this side. So find out which angle is this. Okay, you can go by that method, but here you can directly see 1 upon 2, 10 upon 20 is 1 upon 2, and we remember our 30, 60, 90 triangle that we take only 30 degrees and 1, 2, 3, root 3, and we only remember sine 30 is 1 upon 2. As I saw here 1 upon 2, I am very sure that this angle is 30 degree. I don't need any calculation work for that. Okay, if this is 30, it has to be 60 degrees. Now the sum is very easy. Okay, by Pythagoras you have found out the QR, find out the area of this triangle, radius is 10 degree or angle is 60 degrees, you can find out the area of sector. From area of triangle, subtract area of sector and you will get the area of the shaded region. So please pause your video here. First find out by Pythagoras QR, find out the area of triangle, then find out the area of sector and just subtract. So please pause your video here and solve this example. The answer is 34.17 centimeter square is the area of this shaded region. The QR is 10 root 3. You must have got 10 root 3. Okay, and if you take the directly angle O, sine of directly angle O, it will be 10 root 3 upon 20. That is nothing but root 3 upon 2. Again, you can directly judge that this is a sine, this is a angle 60. But just without, see, sometime it happens that whenever the root values are there, the students get confused, or students are afraid of this root signs. That is why I shown you the way where no root sign in the calculation is involved. Okay, so this is the answer. Let us go to next example. Let us solve the example number 11. This is also not very difficult, though the figure looks complicated. First of all, RQ is a diameter and this is a RPQ is a semicircle with the diameter RQ. Then this is the right angle. You know that angle subtended in a semicircle is right angle. So here RP is 6 given, PQ is 8 given. Now taking PQ as a diameter, this circle is drawn, and taking PR is a diameter, this circle is drawn. And now we have to find out the area of shaded region. It is very simple. Okay, just think properly. Now can you see that this complete semicircle with the diameter RQ is out of the shaded region. That means from the full figure, if you delete or subtract the area of this semicircle with the diameter RQ, you will get the area of shaded region. Now in this figure, there is one semicircle, second semicircle and one triangle. If you add these three areas, you will get the area of complete figure. Correct? So calculate the area of this semicircle with radius 3. Calculate the area of this semicircle with radius 4, because diameters are given. You have to use the formula pi r square by 2. Okay. Then you have to find out the area of this triangle. Now area of this triangle, how will you find out? Half base into height. This is the base, this is the height. Okay, and then you find out the area of this bigger circle, semicircle rather, and subtract, so you will get the final answer. That is the area of shaded region. So what you will do, I will explain again. This is the first semicircle, second semicircle, this is the triangle. So first find out the area of region 1, then find out area of region 2, then find out the area of region 3, that is triangle. Okay, then find out the, for this semicircle, I'll say this semicircle is S. Okay, then find out the area of semicircle S. When you get these four areas, add the area of or required area is equal to A1 plus A2 plus A3 minus area of semicircle. Very simple. Okay, please pause your video here and solve this sum. Answer for this is 24 centimeter square. Please check your answer. In example number 12, don't look at my figure, it is not to the scale. Just consider this is a complete circle. PS and QR are two chords, whereas QS and PR are the diameters of a circle meeting at point O. This angle 120 is given. The diameter PR is 28, that means this is 14 and 14. And then they are given PS is 14 root 3. This PS is given 14 root 3 centimeters. The area of triangle OPS, this triangle, and then the total area of two shaded segments. These two shaded segments area we have to find out. Now when you want to find out the area of this triangle, what you require as per the formula? Half base into height. You require height. So I am drawing a perpendicular on this chord through center, and we know that the perpendicular suspended on the chord through the center always bisects the chord. So this is half of this, that is 7 root 3. Now in this triangle you have base 7 root 3 and height can easily be found out by the Pythagoras theorem, that is 14 square is equal to 7 root 3 square plus, if this is m, OM square. Clear? Explaining again. I am drawing a perpendicular from center O on this chord. Correct? So this chord, this perpendicular bisects the chord as per the theorem. So this will be half of PS. So now in this triangle you have to find out this height OM. How will you find out? By Pythagoras theorem. This is a right angle triangle, and by Pythagoras theorem you can easily find out OM. Now in this complete triangle PSO, of which the area we have to find out, you know 14 root 3 as a base, and this OM what you will get by the Pythagoras theorem will be the height. So half base into height, you will get the area of triangle. Correct? Now going ahead, you want to find out the area of these two shaded regions. It can be easily shown that if this is 120, this is equal and opposite angle, this is also 120. Okay, these two are parallel lines. So this triangle area is also same as this triangle area. Now either you can do one thing, you find out the area of this sector with radius 14 and angle 120 and subtract the area of triangle. So you will get the area of this shaded region, and this shaded region is just replica of that. So double the area of this shaded region, you can get the area of total shaded region. Okay? Other way, angle 120 is given, radius 14 is given, you just have to find out the area of segment. You can directly substitute in the formula of area of segment and you will find out the answer. But the problem in that case is, now somebody will ask me, why don't we use the area of segment directly? In that case, you have to find out the sine 120. And when you have to find out the sine 120, the sine 120 is not given here. They are not given any figures. So without log table, you will not be able to find out that. So here we cannot find it. Suppose we don't have to find out the area of triangle. Still, just by using the area for this segment, you cannot find the answer. So first find out the area of triangle, then find out the area of this sector, subtract the area of triangle, you will get the area of segment. Just double that, because these figures is just a replica of this. Okay? Similar figures. So quickly pause your video here and find out the answer for the total area of shaded region. Again I am telling you, first find out OM, then find out the area of triangle, then find out the area of sector, subtract the area of triangle from sector and you will get the answer. So find out the OM, the area of triangle, the area of sector and area of shaded region is equal to area of sector minus area of triangle, and area is a total shaded area is 2 into area of shade. Very simple. Pause your video here and find out all these answers. Do it now please. Answer is OM is 7 centimeter, area of triangle is 84.77 centimeters square, area of sector is 205.33 centimeter square. So area of shaded region is 120.56 centimeter square. So just double this and you will get the total area of shaded regions. Please check your answers. I am not giving the final answer. It's very easy. This is 241.12 somewhere. Okay. So the final answer will be double of this, that is 241.12 centimeters square. Simple example. Let us go ahead. Let us see example number 13. Simple example again. The segment PQ is the diameter of semicircle PNQ. They are given PQ is a semicircle PNQ. The center of our PNQ is O. This is PMQ and its center is O. The example is extremely simple. I am telling you again and again. In geometry, the students get confused or students scared of the complicated figures. But if you can interpret the figure properly, the examples are very, very simple. How will you find out the area? Forget about the figures. Numbers, forget about the numbers. How will you find out the area? First, find the area of this semicircle and subtract the area of this segment. Correct? To find out the area of this segment, what you need? Angle and radius. You can easily find out the area of segment. Now to find out the area of this semicircle, you need radius. This is the diameter. You need to find out the value of this diameter, which we don't know at this moment. But just forget about this bottom part. Just forget about this. What you can see here? 10 and 10. So this is the isosceles triangle. Opposite sides are equal. So opposite angles are same. That means this angle and this angle must be equal because this is isosceles triangle. Two sides are equal. But the addition of all three angles is 180. So x, suppose this is x and this is also x. 2x plus 60 is equal to 180. And so x is equal to 60. So this is now equilateral triangle. And so this side is also 10. So now you have got the diameter of this semicircle. So you can easily find out the area of this semicircle. You know radius and angle. So you can find out the area of this segment. When you subtract the area of this segment from area of this semicircle, you will easily find out the area of shaded region. Correct? So pause your video, find out the area of semicircle, find out the area of segment and subtract the area of segment from the area of semicircle, you will get the area of shaded region. I hope that you know the formula for area of segment. The answer for this problem is 30.17 centimeter square. So the area of shaded region is 30.17 centimeters square. I am not going to tell you what is the area for segment. You have to remember it. Okay. Let us go to next example. Example number 14 is just an example of combination of 3D figures. Okay. The first figure they are given, we have to find volumes, total volume we have to find out. The first figure is given something like this. There is one hemisphere and here is one cone. They have given this height they are given and this radius they are given. And you have to find out, this is the combination of figure, hemisphere and then above that cone. So here they are given 12.3 and 3.5. Okay, radius is given, means the radius of the cone is also, the radius of the base of the cone is also 3.5. So what you have to do here, you have to first calculate the volume for hemisphere, that is 2 by 3 pi r cube. Volume of the hemisphere is 2 by 3 pi r cube, and volume of the cone 1 upon 3 pi r square h. H is known, r is known, here also r known, so you can find out the total volume. I'm not going to even tell you the answer for this problem. Okay, extremely easy problem. The second figure they are given, there is one hemisphere, and above that, now this is the plane surface, on that there is one small hemisphere, and you have to find out the total volume, and they are given the radius, the diameters they are given, the diameter for this, that means they are given this diameter is 10, this diameter they are given 3. Now there is just one hemisphere, and above that one small hemisphere is put. Very simple. Find out the value of bigger hemisphere, find out the volume of smaller hemisphere, add them, and you will get the volume of this complete assembly, or you can say the modified 3D assembly. Okay, so like this there can be many figures. Okay, there can be combination of many figures, and you have to find out the total volume for that. Now this was the example where the figures were added. Okay, but there can be an example that suppose this is a ball, a sphere, and a through hole is there of say diameter something, and that you have to find out the volume of this. Okay, so in that case you have to find out the total volume of the sphere, then subtract the volume of this middle part, and you will get the answer. So there can be the combination of different figures. Very easy examples. You can expect one example of this kind in your exam. Next, 15th example. Now this is a different kind of example. A building has 8 right circular cylindrical pillars. Right circular cylindrical pillars. A building has 8 right circular cylindrical pillars whose cross-sectional diameter is 1 meter. Diameter is 1 meter, 8 pillars are there, and whose height is 4.2 meter. 4.2 meter is height. Find the expenditure of painting these pillars at a rate of 24 rupees per meter squares. Rate 24 rupees per meter square. Now you have to find out, what you have to find out? Do you have to find out the total surface area or only the curved surface area? These are the pillars. That means this is the bottom part which is attached to your ground floor, and this is attached to your ceiling. There are 8 pillars. So first of all, find out the curved surface area. Now you have to find out the total surface area, that is curved surface area into 8. This is the total surface area you have to paint, and then cost is equal to total surface area into 24. That is the rate. Very simple example. So please pause your video and do this calculation now. The curved surface area is 13.2 meters square. This is 105.6 meters square, and your total cost is 2534.4 rupees. Example number 16. A 10-meter deep well with a diameter 1.4 meter is dug up in the field, and earth from the digging is spread evenly on the adjoining rectangular field. The length and breadth of the field is 55 meters and 14 meters separately. Find the thickness of the earth layer spread. Now this is the example of the two equal volumes. We have seen such an example when we were solving the sample examples. Okay. In that case, well is nothing but a cylinder. Okay. And a rectangular field is nothing but a cuboid. Okay. Now in this case, a well is digged. A well is digged and the diameter of the well is 1.4 meter and the depth is 10 meters. So how much soil will be there with you? Equal to the volume of this well. Now this soil is spread on the rectangular field. Okay, whose length and breadth as 55 into 14. 55 into 14, and you have to find out the height. What is the common in this case? The volume of this well is equal to the volume of this field area. In that case, here you will have pi r square h, and here you will have base length into breadth into height. So here 1.4 is the diameter. Let us see whether it is a diameter or not. Yeah, it is a diameter. So here pi 0.7 square into 10 is equal to 55 into 14 into h. Now in this case only h is unknown, and you can easily find out the value of h. Okay, again I am explaining you. The well is dig. The well is nothing but a cylindrical shape, okay, with diameter 1.4 meter and depth is 10 meters. Find out the volume of this. In this case, that soil is spread on the rectangular field evenly. Okay, the length and breadth is given 55 into 14, and you have to find out the height. And you have to find out the height. So equate the volumes and you will get the h, because only h is unknown here. I can easily solve this example for you here, but I am just discussing and leaving the calculation part to you. So please pause your video here and find out the value of h. Answer is h equal to 0.02 meters. Example 18, a roller of diameter 0.9 meters and a length 1.8 meter is used to press the ground. Find the area of ground pressed by it in 500 revolutions. Now this is a roller whose diameter is this. You might have seen the cricket roller, okay? We roll the pitch of the cricket by this ground roller, okay? The diameter is given as 0.9 meters and the length is given as 1.8 meters. So now you can find out a curved surface area. So the curved surface area is the area covered in one revolution. So if this is the cricket pitch, the area, this is the roller, the length of roller is 1.8 meters. In 500 revolutions, how much area will be covered of the cricket pitch? Very simple. For the roller is a cylindrical one. So surface area for roller is 2 pi r h. H is this. How many revolutions? So this is the area in one revolution. Now this is the total surface area will be covered. This surface area will be equal to surface area of roller into 500 revolutions, equal to, now 1.8 meter, we know that the breadth, so we have to find out the length. So 1.8 into, let us say this is x. So in this case only x will be unknown, because you will get the value of ASR, that is the surface area of roller, into 500 equal to 1.8 into x, and you have to just find out the x. Okay, please pause your video and solve this example. The surface area of the roller into 500, that is the total area covered, will be 2543.4 meters square. Now actually in this example only this is asked. How much area will be covered by the 500 revolutions? This I gave you added. Suppose, because some other problem, in other words, the problem may come that if this is a cricket pitch, so what is the length of the pitch? And in that case you will have to find out the x. In this example x is not required. You have to just find the area of the ground pressed by it in 500 revolutions. Okay, you have to just find out the total surface area covered by the 500 revolutions, but they may add to it that find out the length of cricket pitch. Now here they even they have not commented that this is a cricket pitch, but I am telling you another kind of example. Okay, in that case you have to equate this area with 1.8 into x and find out the value of x. This is the added example. Okay, let us see next example. The diameter of the base of metallic cone is 2 centimeters. Diameter of the base of the metallic cone is 2 centimeters and height is 10 centimeter. Height is 10 centimeters. Okay, so the radius is 1. 900 such cones are melted. Now it is melted. That means you have to find out the volume of cone into 900. That much metal you will have. Correct? This much metal you will have. So first find out the volume of cone by substituting radius and height, and 900 such cones are melted. To form one right circular cylinder. One right circular cylinder. So what will be the volume of this right circular cylinder is Vc into 900. Correct? Whose radius is 10 centimeters. Now their radius they are given is 10 centimeters and you have to find out the height. Now the radius of this right circular cylinder is given 10 with some height, and then you have to find out the total surface area of right circular cylinder. So how you will solve this? You have to find out the total surface area of this right circular cylinder. So first calculate the volume of the cone by substituting into the formula of the cone. I am not going to tell you the formula for volume of cone. You should remember this. If you don't remember, refer to your notes or refer to your book. Whenever you are solving the problem set, when you come up to the problem set, you should know all the formulas. Okay? So first find out the volume of one cone multiplied by 900. That is the volume of this. That is pi r square into h. Pi r square into h. So from here you will get the h. Correct? And once you get the radius and h, you can easily find out the total surface area of this right circular cone. So please pause your video here and solve this example. telling you again, find out the volume of this cone, multiply by 900, that will be the volume of this cylinder. In the formula, only h is unknown. You will get h from here. And once you get height and radius is given, and once you get the h, you can easily find out the total surface area of this cylinder. Please pause your video here and solve this. Your height here is 30 centimeters and total surface area centimeter square, 2512 centimeters square. Let us go to next example. There are two figures or two solids rather I will say. The volume of a cone this is the cone. The volume of a cone of a height 5 centimeters, they are given the height 5 centimeters, volume of cone 753.6 centimeter cube. Now this cone and a cylinder, now they have one cylinder. Have equal radii and height. The radius of this cone and this radius are equal and height is also equal. Okay. This cone and cylinder have equal radii and height. Find the total surface area of the cylinder. We have to find the total surface area of cylinder. Okay. Now by substituting in the formula of this cone, volume of this cone, you will get the value of R. Now since R is there, R is same, this R and this R are same, and height is also same, which is 5 centimeters. Now in case of cylinder, you have height, you have radius, and you can easily find out the total surface area of this cylinder or any identity. If you want a curved surface area, you can find out. You want total surface area, you can find out. If you want to find out the volume, that also you can find out. So first substitute in the formula of cone, find out the radius and then find out the total surface area of this cylinder. Please pause your video and solve this example. The radius is 12 centimeters and the total surface area is 1281.12 centimeters square. So in this case, now in these 2-3 examples, past 2-3 examples, that is right from the example 15, 16, 17, 18, 19 and this 20, in all these examples the figures were not given. You have to draw the figure compulsory. Compulsory means examiner is not expecting the figure. It is not very compulsory, but if you don't draw the figures, you can easily miss the calculations. You can easily miss the formula and you will not understand that particular problem properly. So whenever the figures are not given, if the figures are given, well and good. If they are not given, draw your figures. Okay. Now if you don't draw the figures, still you can easily solve this example because you know the formula, you know you have to find out the R. Here also everything is given, but the figure speaks more and the figure speaks perfectly. So don't forget to draw the figures. Okay. Let us go to next example. In the example, they said there is one cone. A height of a cone is 40 centimeters. So this height is 40. A small cone is cut off at the top by a parallel plane. That means it is cut off by a parallel plane here. Okay. Let us say this is B dash and O dash. A small cone is cut off. Okay. If its volume is 1/64th of the volume of the given cone, if given cone's volume is V, I'll say V big, so V small is 1/64 of the V big. Okay, volume is, this small cone's volume is 1/64th of the original cone's volume. At what height above the base is the section made? At what height above the base is section made? If I say the height of this cone is h and a complete height, that is from here to here, it is h, that is 40. H is equal to 40. Now, since these two planes are parallel, these two triangles are also similar triangles. The triangle AOB is similar to triangle AO dash B dash. Okay, and so AO upon AO dash is equal to BO upon B dash O dash. Correct? Now what is AO? AO is the total height, that is 40. AO is a height. So 40 upon this height of the bigger cone, 40 upon height of the smaller cone h, is equal to radius of the bigger cone r upon the radius of smaller cone r. Once you get this, now we'll come back to the volume part. Volume of this cone, small cone, is equal to 1/64th volume of big cone. What is the volume of small cone? 1/3 pi r square h is equal to 1/64 into 1/3 pi into r square into h. Now in this case, we will have this will get cancelled, pi will get cancelled. Now we have r square h is equal to 64 r square h. Now you have, we will transfer this r there and this h. So we have h upon h is equal to 1/64 into r square upon r square. H is 40, we know. So we have h upon 40 is equal to 1/64, and what is r upon r is 40 upon h? 40 upon h bracket square. Now this is the equation in just one variable. Find out the value of h. Please pause your video here and find the value of capital H, that is the height of this cone. And whenever you will subtract this height from this total height, you will get an answer, because what they have asked, at what height above the base, at what height above the base this cone is cut. You don't have to find out the value of this height. You have to find out the value of this length. You have to find out h minus h, you have to find out, not only h. So first pause your video and find out the value of h. Do it quickly now. Answer is, this h is equal to 10 centimeters. Now this is 10, this is 40, so the required length, the L, is equal to 40 minus 10, that is 30 centimeter. That means 30 centimeters above the base, you should cut a plane to form this smaller cone. Example is not very difficult, it's a tricky one. Let us see this example again. They did not give r and r. They give only the height of this main cone. And they said that this cone is cut at certain height above the base, so that the volume of this smaller cone in 1/64th the volume of the full cone. Okay, so first we got the equation. Volume of smaller cone is 1/64th volume of bigger cone. Now these two triangles are similar triangles, and so we have this ratio 40 upon this h is equal to r upon r. Now we are taking this equation and substituting the formulas for this volumes of both the cones, and from that we got this height. Remember, read example very carefully while checking papers. Once this example was there and 99% students wrote the answer 10 centimeters. They just found the height of this smaller cone. They did not rate that at what height about the base. Everybody neglected, because after this just one oral calculation was there. You have to just subtract 40 minus 10, so that above the base 30 centimeters you have to cut. So please example very, very carefully. Write down what is to be found out, so you will not forget, or on the paper mark, underline what is to be found out. Okay, don't miss this, otherwise you will lose. If I am checking full marks, your full marks are gone. But in board exam, maybe you will get some mark for the steps. But why should we depend on the steps when we know the final answer and we are just fooling ourselves by not looking carefully what is asked? So in this case, though the example is not very difficult, but the trick is they are asked something different and you may write something different. So let us go to last example of problem set. A piece of cheese. This is a piece of cheese. You know that piece is generally a circular slab. Okay, it's a cylindrical shape. Now I cut one piece. Okay, this is the piece of cheese is cut in the shape of a sector of a circle of a radius 6 centimeters. Radius of a circle is 6 centimeters. The thickness of the cheese is 7 centimeters and the degree of cut is 60 degrees. Now they are asked find the curved surface area of the cheese. You have to find this curved surface area of the cheese and the volume of the cheese piece. Extremely simple example. For the curved surface area, first find out the length of the arc. So your length of arc is theta by 360 into 2 pi r. That is the length of the arc. And curved surface area is equal to this length of arc into 7. Curved surface area, this length into 7, that is height. And then what will be the volume of this? Simple. The area of this sector into the height. What is the area of sector? Volume of this cheese is theta by 360 into pi r square into 7. Now this 7 is height. I should write into h or something, but let us substitute direct value. So this is very simple. The curved surface area is 44 centimeters square and the volume is 132 centimeter cube. So friends, with this example we have finished the chapter number 6, mensuration. As you have seen that the chapter is very, very simple. The only thing you should remember many formulas, and if you don't revise these formulas at least once in 3 days, you will not able to remember these formulas. But again, don't forget that how these formulas are formed. So you will never forget those formulas. Okay. Now the important thing in solving the problems on this chapter is always draw figures. Okay, even if the figures are not given in your paper or in your book, you have to draw the figures. Write down what is asked and what is given. What is asked is also important. What is given is of course important. Okay, even if the figures given are a little bit complicated, don't get afraid, don't get confused, because generally those figures are not that complicated, because you don't have that many shapes. You can easily interpret the figure. So the problems based on these chapters are very, very easy. So I hope you understood this chapter. If you have any problems, you can just write in comments or just mail us. We will try to solve your problems. Thank you very much.